The energy of an atom is the least largest negative value when its electron is revolving in an orbit closest to the nucleus. That is the one for which n is equal to 1. For n is equal to 2, 3, 4, etc., the absolute value of the energy is smaller. Hence, the energy is progressively larger in the outer orbits. The lowest energy of the atom, called the ground state, is that of the lowest energy with the electron revolving in the orbit of smallest radius, the Bohr radius A0. The energy of this state, n is equal to 1. E1 is minus 13.6 eV. Therefore, the minimum energy required to free the electron from the ground state of the hydrogen atom is 13.6 eV. It is called the ionization energy of the hydrogen atom. At room temperature, most of the hydrogen atoms are in the ground state. When a hydrogen atom receives energy by processes such as electron collision, the atom may acquire sufficient energy to raise the electron to higher energy states. The atom is then said to be in excited state. For n is equal to 2, the energy E2 is minus 3.40 electron volt. It means that the energy required to excite an electron in hydrogen atom to its first excited state is an energy equal to E2 minus E1, which is equal to minus 3.40 electron volt minus 13.6 electron volt, which is equal to 12.2 electron volt. Similarly, E3 is equal to minus 1.51 electron volt, and E3 minus E1 is equal to plus 12.09 electron volt. Or, to excite the hydrogen atom from its ground state, n is equal to 1 to second excited state, n is equal to 3, is 12.09 electron volt energy, and so on. From these excited states, the electron can then fall back to a state of lower energy, emitting a photon in this process. The energy level diagram for the stationary states of a hydrogen atom is given in the figure. The principal quantum number n labels the stationary states in the ascending order of energy. In this diagram, the highest energy state corresponds to n is equal to infinity and has an energy of 0 electron volt. This is the energy of the atom when the electron is completely removed. R is equal to infinity from the nucleus and is at rest. This is how the energies of the high excited states come closer and closer together as n increases. This shows you that how the energy states of the hydrogen atom is varying and distributed corresponds to the values of n as shown in the Bohr postulate, so that we can observe how these energies are varying and how the atom goes to its excited state as per the rules of the postulates of the Bohr model.